There are mountains in Antarctica that look like pyramids. Not vaguely, not if you squint and tilt your head and want badly enough for them to be something they are not. They have four faces, they have ridge lines, they rise from the surrounding ice at angles that, in any other geography, in any other context, would stop people cold. I want to be careful with language here, because the moment you use the wrong word, the whole thing collapses into the category of things people dismiss before they examine. So I am not going to say they are pyramids. I am going to say they are formations that produce, in the mind of any person who looks at them, the same immediate and involuntary recognition that a pyramid produces. The formations are real. They are documented. They have been photographed from aircraft and from satellite. They sit in the Ellsworth Mountains region of West Antarctica, and the most prominently discussed examples rise with a sharpness and a symmetry that the surrounding terrain does not generally share. Geologists know about them. Cartographers have mapped them. They are not a secret, and this is actually the first strange thing about them. Not that they exist, but that they are so thoroughly known and so thoroughly unexamined. They've been answered without being investigated, which is a very specific kind of scientific gesture, and one that I've learnt to pay attention to. The mainstream geological explanation is solid and well supported, and I want to give it the full weight it deserves before I say anything else. These formations are classified as nunataks, rocky peaks that protrude through an ice sheet. The pyramidal geometry is attributed to a process called glacial erosion, and more specifically to a subtype called freeze-thaw weathering, operating simultaneously on multiple faces of the same rock mass. The mechanism is straightforward. Water infiltrates the cracks in exposed rock, freezes, expands, and fractures the stone. When this happens on every face of a peak at once, the mountain is carved inward from multiple directions simultaneously. Over time, the erosion converges toward a central spine, and what remains is a sharp, multi-faced summit. The geometry is a byproduct of physics, not intention. The most familiar example of this process is the Matterhorn on the border of Switzerland and Italy. If you have seen photographs of the Matterhorn, you understand immediately why the nunatak explanation feels sufficient. It is a four-sided peak. It has clean ridgelines. It is unambiguously the product of glacial forces working on alpine rock over deep geological time, and no one has ever seriously proposed otherwise. I don't dismiss this explanation. I want that to be clear. It is consistent with known physical processes. It is reproducible in laboratory conditions, and the people who accept it are not being careless. They are applying a well-tested model to a formation that fits its predictions, and that is exactly what rigorous thinking looks like. My discomfort is not with the model, it is with what the model quietly depends on. Here is the first detail that doesn't sit cleanly. Antarctica was not always frozen. This is not a fringe claim. This is mainstream paleoclimatology, published in peer-reviewed journals, accepted broadly within the scientific community. The Antarctic continent underwent its major glaciation approximately 34 million years ago. Before that, it supported ecosystems. There were forests, there were river systems. Fossil records confirm the presence of diverse biological life on the Antarctic landmass during periods long predating the ice sheet we know today. More importantly, the glaciation has not been uniform or continuous. Paleoclimate records indicate that portions of Antarctica, particularly in the western regions, experienced significant warming and partial deglaciation during interglacial periods within the Pleistocene epoch, which spans from roughly 2.6 million years ago to approximately 11,700 years ago. The boundary between deep geological time and geologically recent is, in Antarctica's case, genuinely contested. Now apply this to the geometry. The freeze-thaw erosion that produces pyramidal nunataks requires ice. It requires a sustained ice sheet cycling through freeze and thaw across the exposed rock faces. But for the hundreds of millions of years before the ice arrived, those same rock formations were exposed to a completely different erosion regime, one driven by rain, wind, and gravity, which produces rounded peaks and irregular faces, not sharp and symmetrical ones. The pyramidal shape, therefore, can only have developed during the Ice Age. It cannot predate it, which means that the geometry we are looking at is a product of a specific window in geological time, and the precise sharpness of that geometry depends on how consistently the ice has covered and exposed those faces, and in what pattern across that window. That window, as I've said, has not been uniform, and the measurement of how much erosion those specific formations have actually undergone, the quantitative geometric analysis that would confirm or challenge the nunatak model's predictions, has not, to my knowledge, been rigorously published. I want to widen the frame now, carefully, because these formations do not exist in isolation. They sit inside a much larger conversation about the boundaries of what we know about early human prehistory. And I think that context matters for understanding why the questions surrounding them carry the weight they do. The standard archaeological timeline places anatomically modern humans at roughly 300,000 years old. It places the emergence of organized monument-building civilization at no earlier than approximately 5000 BCE. That timeline is not fabricated. It is built from real evidence, recovered from real sites, dated with real methods, but it is built from what we have found, not from what existed, and those two things are not the same. The archaeological record is fragmentary by its nature. We recover what survived: stone, fired clay, metal, material deposited in the right soil chemistry, in regions that were not subsequently flooded or buried or otherwise disturbed. Organic materials, wooden structures, anything built in biologically active environments, these vanish within centuries, let alone millennia. A sophisticated civilization that did not build primarily in stone, or that built in stone in geologically active regions, would leave an archaeological footprint that we may not yet have the tools or the inclination to find. The discovery of Göbekli Tepe in southeastern Turkey, now dated to approximately 11,500 years ago, demonstrated this point with uncomfortable precision. The site required organized labor at a scale previously considered impossible for pre-agricultural human societies. It required symbolic and architectural complexity that had no precedent in the accepted record at that time. It did not fit the timeline, and so the timeline adjusted around it, quietly, without retracting the confidence with which the previous version had been stated. This is not a failure of science. Science is supposed to update on evidence. What I keep noticing is the gap between how confidently the pre-revision timeline was asserted and how smoothly the revision was absorbed without any reckoning with that confidence. When a discovery requires us to move the boundary of known human sophistication back by thousands of years, it should prompt at least some reflection on how firm the remaining boundaries are. That reflection, in most public-facing science communication, does not happen. There is a document I want to bring into this carefully, because it has been used carelessly in the past, and I don't want to repeat that error. The Piri Reis map, drawn in 1513 by Ottoman admiral and cartographer Piri Reis, is preserved in the Topkapi Palace Museum in Istanbul. It is a real artifact, thoroughly documented by historians and cartographers. One section of the map depicts a coastline to the south of South America that some researchers have argued corresponds to the subglacial topography of Antarctica, the shape of the landmass beneath the ice, not the ice surface itself. Antarctica was not officially discovered until 1820, more than 3 centuries after the map was drawn. The mainstream cartographic explanation is that Piri Reis was drawing from earlier classical sources that included a speculative terra australis incognita, a hypothetical southern continent that Ptolemaic and medieval cartographers included because they believed the Earth's geography required a southern landmass to balance the northern ones. The resemblance to Antarctica in this reading is coincidence produced by a lucky guess. This explanation is plausible. I want to say that plainly. It does not require any chain of transmission from an unknown ancient source. It requires only that a speculative tradition guessed at the existence of a southern continent, and that the guess bore a partial resemblance to what was eventually found. That is a reasonable account, and I don't have hard evidence to reject it. What I notice is that the map has not received the kind of rigorous quantitative geographic analysis that would definitively settle the question. The match has been discussed and debated, but the level of precision required to confirm or rule out the subglacial topography alignment, comparing exact coastline curvature against modern radar-generated maps of the bedrock surface, is a measurement that remains, to my knowledge, undone with the specificity the question deserves. I want to stop here and name what I think is the strongest objection to everything I've laid out so far, because it is a serious one, and it deserves a serious answer. The objection is this: if there were evidence of a pre-glacial civilization in Antarctica, ruins, artifacts, structures of any kind, someone would have found it by now. Antarctica has been explored, photographed, drilled, and studied for more than a century. We have radar surveys of the subglacial terrain, we have deep ice cores, we have satellite coverage. The absence of any such discovery is not a neutral silence, it is evidence. I think this is true as far as it goes. I also think it goes less far than it appears to. The Bead Map 2 project, completed in 2013, produced the most detailed map of Antarctic bedrock topography available, and it was a radar survey conducted at a resolution that would not reliably resolve architectural features below a certain scale. The subglacial terrain has been mapped in its broad contours, not in the fine grain that would be required to identify structures that had been compressed under kilometers of ice for tens of thousands of years. Additionally, the regions of Antarctica most likely to have supported human habitation during any hypothetical ice-free period, coastal lowlands, river valleys, lake margins, are exactly the regions that would now lie under the greatest depth of ice. We have not excavated those regions. We have not looked at them with the resolution or the methodology that a serious archaeological survey would require. The argument that we would have found it assumes a quality of looking that has not actually taken place. Now I want to say something careful about why that looking has not taken place, because I think the explanation is more interesting and more structurally revealing than any simple account of suppression would be. I do not believe there is a coordinated effort to prevent investigation of these questions. I do not think there is a room where people have decided what the public is allowed to know about the Antarctic geological record. That architecture of deliberate suppression requires a level of sustained coordination across too many independent institutions, too many competing national programs, too many individual researchers with too many different incentives. The math doesn't work. What I do think happens, and what I think is in some ways more concerning than named conspiracy, is that institutional frameworks develop their own gravitational field. Once a consensus is established, the infrastructure that produces knowledge, grant allocation committees, peer review panels, tenure evaluation processes, publication hierarchies, begins to orbit around that consensus in ways that are invisible to the individual participants. No single person needs to suppress anything. The system does it without anyone deciding to. A researcher who proposes that the pyramidal formations in Antarctica might warrant a different kind of investigation does not get silenced. They get something quieter and more effective. They get defunded. They get published in lower tier venues. They get cited less. They get described at conferences using words like controversial and speculative. Words that, in academic culture, function as a form of social quarantine. The silence organizes itself through professional incentives, not through any named directive. This is not a critique of science. It is a description of the sociology of large institutions which have been studied extensively by historians and philosophers of science and found to behave in exactly this way. Thomas Kuhn described this dynamic in 1962, and the description has not lost its accuracy. There is one detail I have not yet mentioned, and I want to mention it now, not because it is conclusive, but because it is the thing that has stayed with me longest. Several of the most photographed of these formations have faces that align closely with the cardinal directions. The ridgelines run roughly north-south and east-west. This is not universally true of all nunataks in the region, and it is not precisely measurable from the available public imagery with the accuracy I would want to claim anything definitive, but the alignment is visible. It is consistent across the most geometrically regular of the formations, and it is the kind of feature that glacial erosion does not have a clear mechanism to preferentially produce. Glacial erosion follows existing fault lines and crystal structures in the rock. It follows the path of least resistance in the substrate. Mountain ranges do sometimes develop along tectonic lines that run in consistent compass directions, and a range oriented north-south will produce peaks with faces that roughly align with those directions. This is the standard response when the alignment is raised, and it is not an unreasonable one. But it is also not a measurement. It is an explanation offered in place of a measurement. The geometric analysis that would compare the actual face orientations of these formations against what the local tectonic structure would predict, the work that would tell us whether the alignment is within the range of natural variation or outside it, has not been done and published in a form I can point to. The question remains, precisely in the form of a question. What I am left with is not a theory, and I want to be precise about that word, because a theory requires a mechanism, a model, a set of predictions that can be tested and falsified. What I have is a cluster of questions about the timeline of Antarctic glaciation, about the unmeasured precision of these formations, about the unanalyzed parallels in a 16th century map, about the resolution limits of subglacial radar surveys that sit in an unusual relationship to each other. They are not randomly distributed. They converge on the same silence, the same uninvestigated space, the same region of the question that has been answered without being examined. That convergence may be meaningless. Coincidences that feel significant are one of the most well-documented failure modes of human pattern recognition, and I am not exempt from that failure. I hold that possibility seriously. But I also know that history is full of revisions that arrived not because someone invented a new method, but because someone decided to ask the question the existing framework was quietly organized to avoid. Göbekli Tepe did not require new technology. It required a researcher who chose to dig in a place that all previous assumptions had designated as not worth digging. Antarctica is the largest under-investigated landmass on Earth. Beneath its ice lies a terrain shaped by processes we have never witnessed and conditions we cannot fully model from our current position in time. The pyramidal formations at its surface are either the products of physics working on rock over millions of years, or they are something else, and the difference between those two possibilities is not yet a closed question. It is a question that is waiting, with considerable patience, for someone to decide it deserves a real answer. And what sits with me, quietly, at the edge of everything I've described, is that no one, so far, has actually looked.